Hello guys, welcome back to my channel, Boy. In this Simulkuy video, I will be talking about combustion reaction. So right now, I already have a bunch of component lists. Uh, yeah, we could see some hydrocarbon, CO2, O2, N2 for the air, and other stuff. And then for this episode, I will be demonstrating the reaction with two types of reactor. The first one is equilibrium model reactor, and the second one is Gibbs model reactor. Okay, so for the first one, equilibrium model, I need to define the reaction. So here, I already have so the notes about the reaction stoichiometry. So okay, let's go to the reaction tab and add the reaction. We'll put it as equilibrium reaction. Okay. Ethane plus O2, oxygen, equal CO2 and H2O. 1, 2, 1, 2. Remember to put minus for the reactant. Okay. We'll give it name C1. Okay. Second one is ethane. Okay. Ethane oxygen. -1, -7 for 2. Okay. It's 3.5. Wait a minute. Oh, sorry. Okay. So C1 and the second one is C2. Okay, that one C3. So C2 and H2. Okay, yeah, something like this. And because this process taking quite time, I will speed up the process. I will make this behind the scene and see you after the reaction is finished. Okay, there you go. So now we have C1 up to C8 reaction. And I want to add a set named reaction set. Yeah, for active leaves, we will add every reaction here. Okay. And last thing, I will add a fluid package, something like that. Okay. And now we return to simulation environment. Okay. Now we have the fuel here with a certain composition. Yeah, you can use your own, but this is what I have now. Yeah. Okay, I'll put it at 30 degrees Celsius, 300 kPa, a certain mass flow. Okay, now I will put a new stream for air. Yeah, this will be my airstream. I will want to make it in the same temperature and pressure. For the flow rate, I want to make it 9,000. Okay, next thing is composition. Yeah, I want to use the classic composition without argon and other stuff here. So 0.21 oxygen and 0.79 for nitrogen. Okay, and then next I want to have equilibrium reactor. Okay, so in equilibrium reactor we will connect the string, and then we should have one vapor outlet and one liquid outlet. So this is the flue gas, and there's no liquid flow here. There should be no liquid flow here. And lastly, we add the reaction set. Okay, something like that. And right now you could see that we already have nearly combusted air, except we have some methane slip here. Yeah, so this is what we have now. Okay, we could show the table, that variable, and then put molar fraction. Yes, something like this. Methane to ammonia. Okay. Okay, so we have the second approach using the Gibbs reactor. So here we can choose reactor and place the Gibbs. Then I will copy this to stream. Yeah. Okay, for Gibbs reactor, it is very simple. We just connect everything and yeah, directly find the reaction without entering any reaction equation. Okay, so because Gibbs reactor works by finding the minimum delta G, so we don't require any reactions here. Okay, now we will compare the result. Okay, so this is the result. You could see that there is a slight difference here between uh, equilibrium reaction and also Gibbs, yeah, which is very normal here. Okay, so for the CO2, we have like 0.02 difference, H2O, yeah, 0.01 difference. So yeah, quite near. So this is the both ways to make combustion reaction. For me, I prefer more to the Gibbs reactor, so it is more simple. If we have a large number of hydrocarbon, we will not wasting our time to input every reaction set. Okay, so that's it for our video. Thanks for watching and see you in the next episode. Bye bye.